Hello everyone, here is Van Amsen. In today's video, we will tackle an interesting problem about finding the highest altitude, and we are given an array that represents the net gain in altitude between points, and our job is to find maximum altitude the biker can reach. So let's start coding. So first, initialize the maximum altitude and current altitude to 0. So max altitude will be 0 and current altitude will be 0 as well. And loop through the gain list. So for G in gain, add the current gain to the current altitude. So current altitude will be G, and check if the current altitude is higher than the max altitude. So if current altitude is greater than max altitude, if it is, update the max altitude. So max altitude will be current altitude. And finally, return the max altitude. So return max altitude. So simple yet efficient implementation. So let's run to see if it's working. So it's calculating. Yep. So it's working, and we started with a gain of -5. So the altitude are at the highest is just 1. And in second case is 0. So yeah, everything's work. And so what we did here, so we start at sea level, so altitude 0, and we keep a record of the highest altitude we have reached so far. So we then loop through the gains list and adding each gain to our current altitude. So if any points the current altitude is higher than our record maximum altitude, we just update the maximum altitude. So it's really straightforward. And yep, so let's see if it's working for unseen test cases and test it. So yes, it's working, and we have completed 21 days of daily challenges. So everything's perfect, and we beat 80% with respect to runtime, and also 26 with respect to memory. So it's really good. And yeah, our solution worked as expected, and this problem has a linear time complexity, so ON. And as we are going through the gains list only once, so it's relatively simple problem once you grasp the concept. So that's all for today, and remember, keep practicing and never stop learning. Be motivated, and happy coding. See you next time.